In this lesson, we're going to have a look at the quarter turn valve manager, which is this manager here. We have two different types of valves in this project. The quarter turn valve, which simply goes from open to closed and from closed to open. And we have a modulating valve, which the manager for that valve is not written yet. So let's have a look at the differences between an instrument and a device. So the first thing to notice is our instruments didn't have an auto enable. They didn't have a actionable input. So the auto enable is if you're in auto and we send the enable signal on this input here, we expect the valve to do something. So this is our request to generate an output request. So I know that's two requests there, but this is the outside layer here. This is our program interfacing with the quarter turn valve manager to say, I want you to do something. We also have a mode input, and this mode input is if you're in 0, open on auto enable. If it's 1, close on auto enable. If it's 2, open on auto enable and close when removed. So we have three different ways of controlling this valve. And then we have our asset data, because we'll always need asset data, whether it's an instrument or a device. We have alarm group and alarm management, and we've seen these three before. And then when it comes to outputs, which again, we use for status reporting when we're sort of debugging or looking at through the code, we have our healthy, open feedback, closed feedback, and any alarm active. So on the face of it, it doesn't look too different and it doesn't feel any different from our instruments. The main difference is that we have these two control elements here which affect the behavior of how our quarter turn valve manager will respond to requests to do something. So if we go inside and take a look at what's going on, again, this is split into functions. Some of those functions require their own function blocks and some of them don't. So we have an asset operation mode manager, and what this is doing is managing our hand, off, and auto. So for anyone who's familiar with sort of basic control of pumps, valves, or devices, it's quite common to have a hand off or auto selector switch. Sometimes these are physical, sometimes they're on a SCADA system or a HMI. This is just managing whether or not we're in auto mode. Everything runs by itself. Hand mode, an operator selects when to start and stop, when to open and close a valve, for example, or off, which is you're in your safe state. And again, as normal, we have a UDT for this, UDT asset operation mode, and we're continuing this sort of hierarchy approach of the asset is required to have these elements in order to make use of this function. So if we go and have a look at our asset data for a valve, you'll find that we have, if I just make this a little bit bigger, you'll find that we have an operation mode, UDT asset operation mode. And in there we have our push buttons for hand, our indication for hand off auto, and a mode, which is a numerical representation of the current mode, which just makes things nice and easy for HMIs and SCADA, and also retaining the value or the current mode after a power fail or something like that. So that's that one function all wrapped up in its own little function block, which is inside our quarter turn valve manager. And you'll find that in all of the valves, in all of the pumps, in anything that requires the operation mode, hand off and auto. And here we have a network. Let's just make this a little bit bigger. We have a network which is managing the open and close requests when in manual. So again, using the asset data, we have open request. So this will be a manual request, asset data, manual request, open request. That will come from a push button on SCADA, a HMI, or it could even be a physical input if we chose to make it a physical input. And as long as we're in hand, that opens the manual request, or it turns on, the manual open request, which if we just hover over this, we'll see is a instance data static. So it's being retained inside the quarter turn valve manager, and then that holds itself on as long as we stay healthy and as long as we don't get a close request, well, a manual close request. And we have the same thing for the close request here. And what we'll see here, this is something that I like to do a lot of. I don't like to rely on the HMI or SCADA to reset the manual request or reset a button push. Once I've dealt with the button, I like to reset it in the PLC, which means it's done then. You can't have this problem of buttons getting stuck on. So somebody presses the button, it gets turned on here, and then it gets turned off here. So we never have this condition of, if you press a button and then you lose comms or something like that, or your comms is not great, then we don't end up with this being stuck on when it shouldn't be. Just for anybody who's wondering why those are there. So down on this network here, we are managing our open and close requests when we're in auto. And again, we have a description here of the modes. So 0 is open on auto enable, 1 is close on auto enable, and 2 is like a dual mode of open on auto enable, but we'd also need to send the close request when we're no longer asking it to open. So the first two use springs to sort of mechanically push the valve back into position, whereas mode 2 requires an actual output from the PLC to drive in different directions. And we can see that if we look at the asset data in IO output, we can see that we have an open request here and a close request, and these will be the areas in which that we set to true in order to pass to our valve through the output mapping layer at the end of the project. So here we have the code, and basically it's if we have auto enable, which is coming from our input layer, and we're in auto, and we're either in mode 0 or mode 2, then we want to send an open request. And we have the manual here as well. So we're either in auto or in manual. We don't need to do a check for if we're in manual mode, because in order to have a manual open request, which comes from here, you must be in hand mode anyway. So, and then down here, looking slightly different to the counterpart above, we have the close request. So if we have auto enable and you're in auto and you're in close mode, so close on auto enable, then we send the close request, and the same for manual. So manual close request. And then down here we have the same for if we're in dual mode and we don't have the auto enable and we're in auto mode, dual mode, send the close request. So that satisfies all three modes that we're in. And you could put this stuff in a nice little function or function block, or well, we wouldn't need it in a function block, but a nice little function, but actually just utilizing the network in its own right and having everything contained in the network does the same job. I know some people don't like that, but I prefer to do it that way. It just means that I can come and have a look at the network and I can see what this network is supposed to do. Down here, we manage our traveling condition, because there will be a period of time where we are not open and we're also not closed. And basically what we're doing is saying if we have an open request, but we don't have the open feedback, set the status to traveling. Same for if we have an output for a close request, but we don't have the close feedback, then set the status as traveling. And then we also have manage failed to reach position conditions. So notice that all of this stuff that we're doing at the moment it's not making use of any sub-functions. This is stuff just for this asset, just for this quarter turn valve manager. Like none of this stuff can be reused anywhere else. So the manage failed to reach position conditions, if we have an open request and we don't have the open feedback, start a fail to open timer. The conditions for the open timer, the length of time that we allow, is set by this asset data alarms control or control delays failed to open. And that would be somewhere on our HMI or SCADA system where that value can be manipulated and changed to affect how long this valve is allowed to open and close. And then if that finishes, we have the conditions then to say failed to open. Excuse me. We do the same for closed as well. And if either of these are in, then we have a position unhealthy. So down here we have our alarm management. We've seen these before. We saw them in the instruments. So we're making use of the same blocks again. No surprises there. That's the sort of point of this, is to have our subfunctions reusable. And again, that's just picking up data from the asset data, alarms, conditions, failed to open, which was set up here. And we do the same thing that we did in the instruments, which is we pick out our index, failed to open index, apply it to our group, and that will set the alarm up on our SCADA or HMI. And down here we have our alarm management failed to close, which is exactly the same as the above. And we have, I've got the wrong text there, but down here we have our signal error for both limits active. So there could be a sort of scenario where we're getting both the closed feedback and the open feedback. That typically happens if like a cam sticks or a micro switch is stuck or broken, in which case we know we've got an error. So we raise the signal error and we also raise the alarm to say both limits are active, which is always going to be incorrect. Here we have our healthy status like we do in the instruments. The only difference being that we have an additional unavailable, excuse me, which is so position unhealthy, signal error. If both of those aren't in, then we can say that our asset is healthy. If our asset is healthy and we're in auto mode, then we are not unavailable. We are available, like the asset is available for auto control. However, if we come out of auto, we're not unhealthy. We're still a healthy valve. We're just not available for auto control because we're not in auto. So we can still set the unavailable. So we have an extra layer of status reporting for healthy. We have, do we have a problem on these two here, which sets the healthy flag, and are we actually available for control? And it's not possible to be available for control if you're not healthy. So that's where this extra bit comes from here. And then we have a new status for at position. So if we have an open request and we have the open feedback, then we're at the correct position. If we have a close request and we get the close feedback, then we are at the correct position. And that's basically it for the quarter turn valve manager. Everything that we've seen should feel familiar from the instruments that we've been through, but also it's a lot of this is core concept stuff for a valve. So the things like traveling, position unhealthy, the alarm management on fail to open, fail to close, that sort of stuff can all be applied to a modulating valve. The only difference being is the modulating valve obviously won't have the digital inputs for feedback, but you will still need a open request or a form of saying you need to move to this position. You will still need the opportunity to type in a manual sort of value and things like that. So just have a think about how you would change this to a manual, to a modulating valve. And later on in the course, we will go through how the modulating valve works.